This conference will now be recorded.
Okay, guys, to introduce myself Ravinder. I'm working as a MongoDB last 7 years, and I'm working as a SQL DB last 14 years. I do work on Azure Cloud and AWS. I do work on Postgres as well, along with all these technologies. This is about a little intro about myself. So let's talk about the objective of today's demo. So what we're going to cover. The major agenda of this demo is what are the main differences between the NoSQL and SQL basically. When the RDBMS systems are there, which are SQL, since very long they are successful, they are so sophisticated, why we need this NoSQL technologies now in the market. We're going to discuss what are the benefits we are getting, what are the use cases the NoSQL products are fulfilling, and where RDBMS cannot fulfill basically. That we're going to discuss about like benefits. There are a lot of benefits actually where RDBMS cannot fulfill the requirements that are raised by the market and only NoSQL can fulfill. And terms, what are the different terms, when we compare with the RDBMS and NoSQL side especially. And different types of NoSQL products. We have a lot of different products, different types of NoSQL products also inside NoSQL side. Like if it is RDBMS, you take it Microsoft SQL, Oracle, Postgres, MySQL, all that, right? So that way, in NoSQL also we have a lot of different products. We're going to talk about a little about it. And all RDBMS products will, like follow the ACID property model to maintain the data consistency, and all NoSQL products will follow the base property. What are the basic difference between these two? We're going to talk in our demo itself, basically. So what is NoSQL first? So let's talk about that. So basically, like NoSQL is introduced 1998 itself, invented by Carl Stroji, which is used to call as file-based database, basically. NoSQL is not a new product. In fact, it was invented long ago, like 1998 is something 22 years ago. But that time, no one was using this because there was no versatility of the data. Nowadays, everybody have the like a smart device. Everybody can upload the videos, photos through many apps, and they do generate different types of data. Nowadays, things are changed. Like if you take about 10 years ago situation, people weren't having the smart devices basically. So data was actually, the RDBMS systems were serving what was market required basically. RDBMS were sufficient to manage the data what market was generating. Now things are changed. Data is comes in the structured format, semi-structured format, unstructured format. That kind of data RDBMS does not actually fulfill, or it won't accept the data basically if you don't have a structure for the data basically. So when recent times, last 7 to 8 years, the NoSQL got really good like market. The reason behind is it can accept any kind of data in any format in without any schema definition. It is a dynamic schema model. You don't have to define any schema and load the data kind of thing. All NoSQL technologies are like that. You don't have to define anything. It just takes the data as it is coming in any format that comes from the systems basically. So NoSQL represents group of products and various related data concepts for storage and management of large data sets. Basically, NoSQL is big data platform. It is all NoSQL comes under big data platforms only. They do manage a large volume of large set of data. Someone not on mute? Basant, can you go on mute, please? Right. Thank you. So to understand the basic difference, guys, let's discuss architectures first. How the Mongo products or NoSQL product works and how RDBMS products work. Just for the sake of understanding, first we will go through the architectures, then we will get into the slides back again. Like I'm going to explain every point what we have in the slide, but you will understand well when we understand the architecture. If it is RDBMS basically, if it is RDBMS, you will have large volume of data in RDBMS systems. What do? You will add more disk drives and stripe the data to different drives to scale with IO, right? To scale with IO, you'll add more and more disk, and if more disks already added, still data is growing. What do? You'll expand the existing drive. You'll expand the existing data to accommodate the data. So the more data, the more CPUs you have to deploy, right? The more data the more CPUs you have to deploy on the server. All RDBMS systems are core-based licensing model. Okay, so the more cores you deploy on the machine, the more cost the licensing cost would be of the product, right? So, and it's not about the licensing anyway. If your data is roughly 3 TB, 4 TB, 5 TB, you can manage. But data goes into 10 TB in a single server, that RDBMS cannot be managed. It can manage. The problem is you cannot do the data maintenance activities like rebuilding, reorganizing indexes. You cannot do it because 10 TB data, if you are doing it, it takes days basically. When you are doing the rebuilding indexes, you need a downtime basically. There will be locks on the tables when it is going on, and it will impose the load also. So when the data goes beyond the capacity of one server, the RDBMS does not fit for the large volume of data basically. Okay, it will process the data. The problem is you cannot do the maintenance activities on the large data systems on which you load into one system. It is not something RDBMS does not. It will support. The problem is you cannot manage the indexes part, performance related issues basically. So this is a limitation of the RDBMS first thing. And if you wanted to manage the high availability of the RDBMS, you will spin off, you will add one more server to have the as a standby data basically, which is read only all the time. These are all read only you can write into one copy, which will act like a primary in any of the technology. Even if it is Oracle rack concept, you write into multiple servers, but it will go to one storage basically ultimately. So at any point of time in all RDBMS technologies, you write into one copy, other copies will be standby. So you cannot load balance the write operations here basically in all RDBMS systems. That is also another drawback. First drawback is keeping the large data sets in a single server is not good thing for the RDBMS systems, because you cannot do the maintenance activities like rebuilding, reorganizing, and taking the backup also will take days and days. So that will overlap with the business hours, which can take the load, right, when you take the backups kind of. So all that is something maintenance kind of issues will rise. If it is NoSQL family, all NoSQL family will follow the distributed computing model basically. So if you talk about Mongo, which is a family of NoSQL, which will follow the replica sets. Replica sets again will be formed into sharded group. So each one replica set will hold the one chunk of data. So let me draw it and explain this how it works. Just let me explain the diagram. Then we'll come back to the slides anyway, so that you understand. Okay, so I have the 4 shards, each replica set called as a shard here. Anyway, we're going to do live configuration of shard, how data movement will happen in the shard. We're going to see byte by data, byte by byte anyway. But first try to understand the technology difference, how it actually scale with the data, how it will give the availability basically all compared to RDBMS. So it has a lot of like a lot of use cases where these products can fulfill, but RDBMS cannot. That's why we have to discuss the architecture first, then get into the slides. These are all application servers, and you'll have the Mongoose servers, which is like a router server. It is like a load balancer. In fact, in Windows servers or for application servers, you have a load balancer, right? And these are all config servers. So we will do this entire configuration with the complete steps. Replica set 1. Let me explain the architecture so that you will catch well, so that the discussions will become easy basically when you understand the architecture, in fact. Right. So first, applications will contact the Mongoose, which is actually like a front end for the application. This is where the people do connect. They can hit one Mongoose or two Mongooses, depends on the connection string they have it. This Mongoose again will contact the config server. Config server will distribute the load to all the servers in the background, all replica set. So if I have 1,000 records, assume a case, 1,000 records I'm loading it. So if the collection is sharded, so 250 records will load here, 250 here, 250 here, 250 here, 250 here. Automatically, data will stripe automatically into multiple servers. Again, the same data will be replicated to multiple servers. So data is actually one. If I have 1,000 records, 250 records, 250 records, so everywhere data is different. If you look at Data is not same in each shard. It is distributed already. When it is writing itself, data got distributed into 4 different servers, not into one server. This is called distributed computing model. Basically, one single operation is writing into 4 different servers. You can read from 4 different servers again data, because data got already distributed. So whenever the application contacts the Mongoose will contact the config server. Config server route the connection where it has to write, how many shards are active at the moment, how many servers it has to push the data. The config server will maintain that data basically. So if you have a 10 TB data, 10 TB data here, it will 250, 250, like 2.5 TB, 2.5 TB, automatically data will distribute. You don't have to do anything. You have only one shard. You added one more shard, it will become 5 TB, 5 TB. Automatically, it will distribute the data. One single command is enough to add the shard to get the data distributed automatically. You don't have to do too much of complex configurations on the Mongo side basically. If it is a RDBMS system, the problem with the RDBMS system is you have to write into one server. In a SQL server, you can only write into one. You can have multiple secondaries where they are read-only copies. You cannot write basically. If it is a Oracle, there is a data guard concept, right? So in Oracle also, what do? You'll have a multiple servers you can write, but ultimately these multiple servers will point to one storage basically. You can write into all different servers on physical boxes, but ultimately all will point to one single storage basically. So again, you are pointing to one target. That's the ultimate goal. All RDBMS will follow this kind of thing. Again, if you wanted to have, you can maintain this copy and then read and kind of thing anyway. But here you are ultimately talking to one server when you are writing, one target when you're writing. When it comes to the all NoSQL family products, they do follow. Sorry, I have to close all of this. Fine. When it comes to the like NoSQL family, it will follow distributed computing model. It is writing the data into multiple servers. See this? Like
Ravi, I got a
parallel.
doubt. Can I
Yeah, go
ask a
ahead,
question?
please. Yeah, of course.
Yeah.
Go ahead, please.
Ravi, here, yeah, you're saying 250, 250, 250, it will distribute in 4 servers, 4 replicas. Then when the application hits, and
Hmm.
then application want uh, 750 record, 749 record, then how it knows that that replica will be available in this replica set, and it will fetch the data from here.
It has the starting data will be divided into 16 MB basically. Each document will be, it will have the data, starting point, ending point basically. It will maintain where the data is actually divided. It will have a chunk basically, plus 64
Okay.
MB data. Each chunk will hold the 64 MB data. The 64 MB data is starting value and ending value will be there. So it is like a lookup, kind of, it is an index basically. If you are looking at, it is starting with 1 and 20. This chunk is sitting on the shard 1. It looks this range, it will route the connection directly there and it will fetch the data.
Oh, okay. Then is there a possibility that 250 record will happen crash, and something happens to that data, then we will not be able to access that data?
Right, it is possible. That is a good question. See, one replica set is down. Out of 1,000 records, 750 records still available. Though
Okay.
one shard is down, you don't be down completely. Whatever the data it is available, other shards are still operational. Even three shards are down.
Sorry to interrupt you. This is Shiva here.
Yeah,
If
go, sure.
I totally agree with you. If 250 one row is gone, it
Mm, mm, mm.
if data is distributed, it will be inconsistency, right?
Inconsistency, but here, whatever the data is available, at least you can serve to the business. If you, as long if your query is falling into this range, temporarily you might be not accessing that data, but you have your own recoveries. You will have own, how you can build the system back online. Till that time, the people cannot access that range data, but other data can read it. If they are hitting this, they'll get the errors anyway, because it is trying to contact that shard. It is not available. That range data, when they are trying to read it, they'll get the error clearly, because shard entry is there in the config server. Shard try to look for the data range, but shard is not online. It will throw the error to the application.
Do we have a mirroring concept also here?
Here it is, here this is the mirroring. See, you're writing 250 records. 250 records are moved here. It is not a server level mirroring. It is not database level. Complete server to server replicate here and here also. So 2 copies will maintain. Even one is down, other one will become primary here. It will serve the data automatically. The probability of going the entire shard is very, very, very rare. The entire shard down is a very rare combination because you have 2 more machines to serve the data. Though this is a primary, for this primary you have 2 secondaries here. If this primary goes down, one of the secondary will become primary and start serving the data.
Yeah, hi, Ravi Srikant here. So I understood that in each replica set you have three machines. So if one machine go down, then remaining 2 available. So those 2 will from those 2, one will become the primary. Then
Yes,
it will serve nothing.
right.
But the conflict here, you said in RDBMS, when the data is more, we need to use more CPUs. But I think more or less here also we're using the more CPUs, right? So
More
when
machines.
you are
That's good question actually. So this is the
yeah.
commodity hardware. You no need to go to the server class hardware. It is just the cheapest hardware where you can run because you are
Mhm.
striping the data. The more data, the more shards you'll add it. The more shards you'll add it, the more distribution can happen. Why? Because you're writing 1 GB data. 1 GB is data is written into 5 different servers. Your IO is striping all the time. So
Okay.
it can run on the cheap hardware also. You are not flooding one
Mhm.
machine. So
Oh,
it runs on the commodity hardware and it is a
okay.
open source. You don't need to pay single penny if you are running the community edition. So community edition can support up to 100 TB, 200 TB also at free of cost. You don't need to pay single penny to the product. Only when you go to the enterprise you have to pay it. If you go to the RDBMS, there are a lot of limitations. On the open source, you have a lot of limitations. But on the NoSQL side, there is no limitation. You can scale your data up to TBs of data on the open source editions, basically. That's a big advantage to the people. We have 90% of the infrastructure we are running on the community edition only. The sharded clusters also we are running on the community edition without any licensing cost at all.
Okay.
Okay. Okay.
Ravinder, just one small question here.
Yeah,
Hello.
go ahead. Yeah, go ahead, please.
Yeah, Ravinder, you said, see, for example, this first 250 records server corrupted or something crashed. Automatically, it won't become primary and it will serve that data.
You see, the other one will become automatic primary because it is already
Primary, right?
synchronized
Then,
data, right?
yeah, then there is no
Yeah,
concept of in concept of inconsistency, right? It will no
right. There is
manual intervention is required.
no manual intervention. This technology take care of on its own almost every time. You will see the in a year
Okay.
once or twice you might see that there will be two secondaries are gone and one will be left. That will stay as a secondary only because there is no enough voting. When we see in practical, you get to know more in details anyway. We'll try to understand the architecture, how data is getting distributed. When you are writing the data is writing into multiple servers. When you are reading the data also, it is getting read from the multiple servers. So the load is getting
Okay.
distributed to multiple servers. That's the advantage here.
Okay.
If you
Fine.
go to the
Fine.
RDBMS, yeah, go ahead.
Yeah. No, this
Santosh,
distribution
yeah.
is any mechanism or else
It's a
any
default nature.
concept we have to use?
You have to
Default
configure
nature.
it.
Okay.
You have to configure the distribution, the routing, everything is a default. It happens by
Okay.
default. Few command configurations are so simple in the Mongo. Few commands will do everything for you. Basically, it's not too much of complex configurations. We're going to
Yeah,
run through the entire configuration anyway.
Ravi
Yeah, go ahead.
here.
Okay.
This may be a blunder question, but I don't know.
Yeah, it's okay. It's okay.
A,
Not an issue. Go ahead.
for me, I have a SQL server. I only need
Mm,
one server. If I'm not going with any high availability concept and everything, just I need
right.
a standalone server. Just I'll
Mm,
install SQL Server Enterprise Edition. In this
mm,
case, I want to if I want to go with the without high availability and sorry whatever here replica sharding, then
mm.
how many servers are required and what is the minimum configuration is required for the Mongo?
See, you can run one server also without any sharded. You don't need these many servers, in fact. So
Oh,
the
okay.
it can be one machine which is a standalone. If it is down means down. 3 machines with a replica set. okay, which will protect the data in case of one down, one will protect. Other is a sharding. Sharding, you're distributing the data because three servers are not this one server you're writing all the time. These are all getting replicated. You're getting the availability, but not the scaling. The server scaling is not happening. So as data is growing, you add more shards. This sharding will concept will come into picture. So that way it is.
Okay.
You have all the options, of course, here also.
Yeah.
You have all the options. Okay. As you see, why I'm discussing this, because this is where you get the benefit of the product. Okay.
Ravinder, hello.
Yeah, go ahead,
Thank you.
please.
Okay, Ravinder, can you open that previous slide again? That Mongo's config servers.
Right. Okay.
Okay. Mongo's is like just trying to understand. Is that a configurations like Mongo's database server? Is that? Like,
it's not a
server
database.
in the sense what is?
It's just a service which will take your connection directly to config server and get the metadata where data has to be written, and then it will go and write the data directly to shards. This writes the data automatically to shards by contacting the config server. Config server knows that where it has to write, because it
There's a
will
server,
have all the...
and there's another separate physical server, isn't it? Like config
Yes,
server.
everything.
It is a part of same server.
No, if you look at this one, total 20 server, 23, 25 servers you need for this one. 25 servers for this set.
Okay.
Different
Config
physical
server in the sense that's a separate server.
Config data also will get replicate. This, if config is down, entire cluster is down, because you have the entire metadata here.
One question.
So database server we're calling as a replica set only.
Yeah, database replica, each replica called as a shard. One shard, shard 2, shard 2, shard 3, shard 4, like that. Yeah, go ahead.
Hey,
So can we call
Ravinder,
that as a
this
database?
here. Yeah, I have a question. So even if cluster is down, but we can, I think we can access the data from the shades, because we can have the metadata, read only data from the config server.
No. See, only Mongoose will contact the config. That's how the architecture. You cannot contact the config directly and get the data. It is only, it runs, Mongoose runs using the config server information basically. It runs, the service comes online, only config is online. If this is down, this will be down automatically. If this is down, again you cannot use a config server. So it is highly interdependent. If you read from the backend shard, you get only the chunk of data. You don't get the consolidated data, because data got distributed already. So you have to come through this only to get the entire consolidated data.
I think at least if we have the one secondary node also, we can run the
Read
application can run the queries and all.
You can read, yes. If one of the server, this is, both are down, this is not writable copy, you still read from the cluster, from this chunk, but you cannot write. We will see all this in action anyway.
Okay. Mongo is, you're saying this is service only, right? The config also, is it service or any data like major?
It is also service. Config server is also service. Mongoose is also a service. Mongodb also a service. We're going to talk about this. No need to worry. Understand the architecture.
Is it mandatory to give separate server for this, or else can we merge these two, config and config server and Mongoose in single server?
No, don't merge it. If one is down, entire thing is down, right? So if config server, there are 3 servers. If this goes down, this will become primary. It will serve the data from here. So you need more redundancy, more availability.
So is it is a mandatory for Mongoose, we have to maintain separate servers.
Yes,
but
yes,
it is a cost effective, right? Again, if you go for individual server, a cost will get increased, right?
If the shards can have, if you have 20 GB data, you might have on each machine 600 GB RAM. Here you can have only 20 GB RAM. 20 GB. It is not processing the data. The backend shards are processing the data. It is only routing the data to requester and taking the data from the backend. So this can be lower configured machine. The backend servers are high configured servers. So there will be no problem. Okay.
Ravinder, Rajesh here. I have one question.
Yeah.
So you drawn 2 Mongo servers, right? Are they going to work on a load balancing model or?
Yeah, load balancing, of course. See, See, you are contacting the Mongoose. Mongoose is writing into multiple servers. It is only can write into multiple servers. So it is doing the load balancing by distributing the data to multiple servers in the background.
I mean to say the two initial Mongo servers there, the Mongos
Each one act like a standby. Like
individual,
it's like a one router, a second router. Both does the same job. Some
like
servers
in
can go to here,
listeners.
some servers come here.
Okay, got it. Thank you.
Yeah, fine.
So both are active, mongoose.
Yes, both are active. Both are can be reachable at the same time. If this is down, they can use all the time this. If this is down, they can use both parallelly. Absolutely, they are different servers, and they are pointing to same config anyway. Okay, we will do this. I'm going to do two mongooses and config servers, charts, how data is distributed to multiple servers. We're going to see live. We can see that how data is migrating also in the background with all the queries. Don't have to worry. Understand the architecture first. We will see end to end. I'm really expertised into this technology anyway. I'm working on since very long on this technology. All possible issues I have created. You don't have to ask the question. I myself create a lot of scenarios created. I'll break things and fix things. That's how the entire course will go on. Right, come back to slides again. See, NoSQL means the full form is not only SQL. You have SQL, which is a relational database systems, basically. Along with that, you have NoSQL, which means not only SQL, which is built for the new generation systems, basically. See, olden days, the NoSQL was never been used because there was no such requirement. Now people are using social media, using different apps and generating different type of data. Let me explain one more thing before I come to the slides. If it is RDBMS system, if I read this data, there is a structure for a table like S number, S name, S number, and S address. If I'm trying to insert the data into that table, I have to follow the structure. Insert into student, just for sake, and try to follow this. Values, okay, and maybe I applied primary key here, I guess. So what is the value I have? 10. So I'll go with 11 then. So if I'm going here, I'm trying to insert some data here, okay, and giving the phone number also, some phone number. I'm violating the structure. If I'm trying to run this command, it'll throw there. Columns or number of supplied values does not match the table definition. You defined a structure, and that structure, whatever you have it, you are supplying more values into the table. The table has only 3 columns. You can only supply 3 parameters, in fact, 3 values to the table. But I'm trying to load fourth value, which is not actually fitting into this table because there is no such definition defined. If you come to the Mongo, this is a Mongo server. Don't worry, how did I install all that? We have a topic we're going to discuss when we start the installation. So show DBs, I do have this database. I'm going to create a database. Creating database here is use database, that's it. So I'm going to create a lab database here. That's it, it got created. Use database name, it will create database automatically. And db.student, I'm not creating the collection also. It will create the collection automatically, take the data automatically. So it is a dynamic schema model. You no need to define anything. It takes the data in any format, any kind of data. So example, I'm inserting 2 records in the first one. Second record, I'll go with the address. Just try to follow. Just for the understanding sake, I'm doing this. Address. Second record, third record. Look at that. First record has two fields. Second record has 3 fields. Fourth record will have a 5 fields, 10 fields. Doesn't matter. Every record can be with a different structure. It doesn't matter. That is what is called dynamic schema model, basically. Okay. So phone number. It can take any data in any format. You don't need to define anything because that's how the nowadays new businesses need it. So they don't have to define things and load the data. Everything is agile in nature, right? Email kumar@gmail.com. You see here db.student.find. You go and read the data. See, first record has 2 fields, which took two columns here, assume a case, two columns kind of thing. Field means column here. Here you will see the 3 fields. Here you will see the 4 fields. Here you see the 5 fields. So there is no structure defined. Still, it is taking the data for every row as a different structure. There is no dependency here. One row can have one structure, other row can have other structure. It can accept the data in any format, in fact. So there is no
రవి
yeah.
రవి జనరల్ గా వీళ్ళు ఇప్పుడు మనం ఒక ఆర్గనైజేషన్ ఉంటే జనరల్ గా వీళ్ళు ఈ స్టాండర్డ్ ఫాలో అవుతారు కదా, ఐ మీన్ లైక్
Yeah, that is
హ్యావ్ ఏ
there. No, here the product by default, it won't impose any schema structure
ఓకే
here. You can impose. You
ఓకే
explicitly, you have to define. We have a schema design and validation, different
యా
module basically. By product, it won't enforce. You have to explicitly add the rules if you want.
యా ఐ గాట్ ఇట్.
So see, if you see the application logs, if you see the system generated logs, if you see any kind of, if you go to the Facebook, someone uploads data, someone writes the comment, someone uploads the photo, someone do something. So that is something you cannot expect that what each user is going to load, right? So how the system has to accept that data? That's entire
No,
social media
the thing
platforms run
is
on the NoSQL.
that yeah, that is concept, Ravi. How, because you have experience, right? How the organization will do, I mean, how the organization will configure a DB schema? Is it like just they leave for the dynamic schema, or they will based on their requirement, they will create a schema and they will follow that insert updates
Both
based
will
on
be
the
there.
created schema?
I understand your point. Both will be there. That is a one module we going to spend. Two classes will spend that. How you define the schema, how we can load the data explicitly, not by default. If you want, organizations will go with the without the schema, with schema, both the cases. Mostly without schema only, 90%. 10%
Oh,
they'll impose the conditions. Only if these fields are there, then accept the data. If these fields are not there, don't accept the data. It's not the entire structure anyway. Only they will validate few fields. If the fields are there in the input, then take the data. That is called a schema definition kind of thing. We will see that. No need to worry.
yeah.
That area will be covered in detail. Now you need to try to understand, guys. RDBMS does not support undefined data, structured data if you're trying to load, whereas all NoSQL families will accept the data in any format. It can be structured, semi-structured, or unstructured. In fact, it is a dynamic schema model.
Ravi, what about data types, Ravi? You haven't specified anywhere.
See, the quotations will form the string, and if I'm giving the number, I did not give anything. See here, for name I gave the string. String is here. Boolean value string. You have a 4 or 5 data types here anyway. We're going to talk about that.
All right, thank you.
Okay.
Ravi,
We are just
Ravi,
go ahead.
why are we calling is a document-based structure? Like, what are the like? Why are we calling in that way, like document-based? Like, in the
Everything.
Cassandra, it's a NoSQL, right? That's different, right?
Okay. Mm-hmm. Yeah, NoSQL only.
But the
That's correct.
Cassandra also similar structure. It's a different structure. Like, similarly, the Cassandra also same thing, right? You can insert. There's no specific structure
Right.
to follow. You can insert the similar. But why are we
Right.
differentiating? Is it MongoDB is a different document based and Cassandra is a like I don't know, big Indian. What is it? BigQuery.
Right. Actually,
Something.
that goes with the columnar database model. This will go with the
Yes,
documented data
columnar.
model. That is columnar means you have the concept called, it will read based on the column basically. It will read based on the document basically, row by row. Row is a here document. In RDBMS term, you will call a collection is a table. A row is a document here. A document is can contain the key pairs. This is a key, it is a value, key and value, key and value. So key pairs, document structure model, the MongoDB follows the document model, and it will have the key pair values in it, key and value to the key basically assigned. So both are different products in terms of how you retrieve the data, how you load the data. There are different things basically. It will accept any
Okay,
data that is
this
there.
contain this
The
contain 4
architect,
rows. That means 4 documents we are calling here.
yes, it is 4 documents now.
4 rows
4
means
documents
4
now.
documents.
That's correct.
Okay.
Yeah, but that way it is.
Okay.
Right. So come back to the slide, guys. Yeah, see, NoSQL, all NoSQL platforms called as a big data databases. They maintain huge data. So the NoSQL products are built for the large data sets, not for the small anyway. Small also you can use it, but it is expected that it can manage the large data sets basically. Okay, this is a new SQL, new generation, third generation databases. These are all latest databases. Actually, it's not old or that these are implemented very recently, last 10 years. These are all got really good market in the response in the market, because the data got versatile, and the RDBMS does not support that kind of versatility of the data. So that's why these products are shining in the market. Non-relational, there is no relation. One row does not have the relation with the other row. One collection, the student collection, does not have any relation with the other collection. You cannot join the collections here. In RDBMS you can join the collections. Here you cannot join. You have to put the entire data into one collection only with the embedded document structure. Embedded documents we're going to talk about, which is equivalent to joining the tables. You have a student information. Student have the address information. Address, you have multiple email addresses, multiple addresses, multiple phone numbers. Everything should go into one record only about one entity. That rule and regulations we're going to talk about in the database design. We have this third module, design, database design in the Mongo. There we're going to talk about in detail about how we can architect a database. Okay. Then it runs on the commodity hardware. It runs on the cheap hardware. You don't need to go to the server class hardware. It can run on your laptop hardware also, desktop hardware also, because you are not flooding one system at any point of time. You are writing into multiple servers when sharded configuration is implemented. You have a standalone, that is a different story. If you have a standalone, you are writing into one server only. If one server crashed, entire thing is down. You have a replica set, you still write into one server, and it will get replicated. If this is down, the other server will be available, right? So that way it is. So if it is RDBMS system, you will have as I said in the beginning, your data, you have a database files are striped into all the drives. Assume a case, if one drive is corrupted, entire database is down. Even one MB of data is corrupted, 10 TB database will be down. 1 MB of data is corruption, 10 TB database is down in the RDBMS system. Whereas in NoSQL family, a shard is completely down. One shard is completely down. Still, cluster is operational with available shards. It is not a single point of failure. RDBMS, absolutely single point of failure. If one file is down, whatever is given to database, the entire database will be down, right? One drive is offline for some reason, entire database will be down because one of the file is sitting in the drive. But whereas if you compare with the Mongo, even one entire shard, the big lot of data here sitting here, still it is down, the available other data will operate. So it does not follow single point of failure. It will give you more availability, more scalability, and dynamic schema model, right? It is following the dynamic schema model, open source at the same time. So a lot of benefits we have anyway. I'm going to conclude all the points at the end. It is open source. You can run, like enterprise, there is a paid version and there is open source, which is absolutely free. Both are equally capable of processing the data. Only the deprecated features are you don't have an automated monitoring system, there is no automated backups, there is no encryption, there are no monitoring tools integration for the community edition. There are certain, the things are deprecated. They cannot support, they cannot give everything in the free open source, right? But data managing wise, community edition, enterprise edition, both are as good as, both are same in terms of data handling. Only features will be missing. That's a great thing. Schemaless. Schemaless means it is a dynamic schema. You don't need to create a database. You don't need to create a collection which is equivalent to table. Automatically it will create on the fly. If it is RDBMS, you have to define the database, you have to define the table and define the structure, then load the data. You have to define all of that. Here nothing need to be defined. Database creation is also on the fly, it will happen. And collection creation on the fly. All the documents in any format will accept the data. So developers no need to think of backend. Backend will dynamically build everything. If they wanted to implement something, they can implement from the application straight away. So it is possible in the NoSQL family. Highly available. If you have the replica set here to protect. Again, you have the sharding to distribute the data, and when you're writing the data, it is distributed. When it is reading the data, it is got distributed computing model, it is following. So that way you get the high available, high scalable, both are achievable compared to RDBMS. It follows the base properties instead of asset properties. What is a base property? We'll talk at the end of the discussion anyway. Mostly runs on the cluster. If it runs on the sharding, then only you get all these, whatever I'm talking about. If you're running a standalone also can run, but there is no benefit. If the server is down, means application is down, there is no availability. If you're running the replica set can accept the data maximum what it can accept. If it goes beyond it, it will also have the performance issues. Again, you have to turn into sharding. Standalone, replica set, sharding. That's how the you have to move hierarchy by hierarchy to process the large data set. Why NoSQL? So the NoSQL, why we need it? Anyway, we know that it is a schema, less a dynamic schema model, open source, and it will give high availability, high scalability, right? So these are all one of the major points we need to consider. It resolves the challenges faced in storing, managing, analyzing, and archiving the data. If it is RDBMS, you have to push the data from the live databases to standby database to offload the live database. If you keep everything in the live database, you cannot do the rebuilding, reorganizing, all that, right? If you need that archiving data, you have to separately point the connection to read it if required. So that way you have to go it, but here you don't need it. Everything can sit in the same collection. You don't need to archive basically. It is already striped. And data in the explosion of data in social media sites like Facebook, Twitter, with the large data nets basically. Actually, I'm going to give you a fair idea how Facebook operates, how Twitter operates. There are billions of people are accessing the Facebook at the same time. How they are actually giving the response to everyone without a downtime. How things can happen. So that's something we're going to discuss in the entire course model. When I discuss that design, schema design, locking mechanism, how data will be operated in the Mongo side, there I'm going to explain that how all the people can parallelly access the data in the NoSQL side, whereas in RDBMS they cannot. So we'll see that. That will be concluded. Need of continuous data availability. Social media, you never see that it never go down because it runs on the distributed computing model. There are thousands of servers are there for a single platform, and one set of the server is down, other set will take the load automatically. So you don't know that how your request is served, but there are hundreds of servers serving one single request. It is possible. Need of more flexible data model, because social media you cannot expect who is going to load what kind of data. They have to accept the data in any format, in fact. So to accept the data in any format, you need absolutely NoSQL. RDBMS does not support it all. So NoSQL database, great solution to growing scale of databases and the falling price of commodity hardware. This is one thing, guys. If you take about 5 years back, you buy it, like a 4 GB pen drive. 10 years back, it used to be 4,000 or 2,000 something, right? Now you get 64 GB pen drive for 2,000 or 4,000, right? So the hardware cost is coming down, year by year. If you compare, it's not going ahead. You're coming back. I mean, you're coming down. The more, the cheaper the hardware, the better this product will be for you. Why? Because it runs on the commodity hardware and it is open source. So the more data you're loading on the cheaper hardware, you get the lesser cost to maintain the data. So that way it is. Consists of column-based data stores, key value pairs, and database and document databases. These are terms, guys, for the products. Offers capabilities to handle the large volume of data using the various available features. So the sharding is one of that, which will make your data always available and absolutely scalable with a large set of data. Benefits of NoSQL. Basically, this will conclude why we need to implement the NoSQL. We already concluded, but anyway, continuous availability are no single point of failure. Your server need to be always available. Okay, no single point of failure. Though one shard is down, the cluster is operational. If it is RDBMS, one of the data corruption, one of the file is corrupted, within the file itself some segment is corrupted, still database is not operational. But NoSQL products are not like that. Even one chunk is down, the entire chunk is down, still the other shards will be operational. Multi-data center capabilities. Here in the diagram, if you look at here, I'll keep two servers in the primary zone. other one server in a secondary zone, secondary data center in the sense. So this will serve the all the write operations. This will serve only read operations again, and you will keep the priorities. Which one to become primary? Primary goes down. You can make the priorities. Which one should immediately take the role, primary role, out of all secondaries? That we can define. We're going to configure it. We're going to see that in practical anyway. So two servers in primary, one server in a remote region. It is possible. That is called multi-data center, operability basically. Easy replication for distributed location independent capable. See, it is so simple to do the configuration. Basically, it's so simple. It is not too complex technology to configure it. Basically, when it has to maintain, you have to understand. That understanding I'm going to give you in and out. Okay, how we need to understand the product, how we need to support the issues. Basically, my program always, I keep any course only purely practical oriented. Theory you can get it anywhere. Theory also will cover, but more of practical side we will focus basically. High performance with a linear horizontal scalability. See, this RDBM systems will follow the vertical computing model. Vertical means as the data is growing, you keep add the resources to one single machine. Vertically it is growing. But if it is NoSQL family, the more data, the more servers you keep added. The more servers you keep added, the more capacity is getting added, and servers distribution will happen automatically. And one request is given by all the servers parallelly. This is called horizontal computing model, we'll call it. The all RDBMS will follow the vertical computing model. Vertical computing model, because you're keeping everything in one server and doing the operations from there. That's why it is vertical. This is horizontal computing model. Flexible schema model. Dynamic schema or schema less or flexible schema, these words are interchangeable, and that's how it is. We have seen right here, he loaded the data. It is accepting the data in any format. That is what is flexible schema. I did not create a database, use database, that's enough. They can use in the code itself. It will create database automatically. And the collection, the student collection also I did not create basically. In fact, I just inserted, it created the collection and loaded it automatically. So that's how it is. Easy to implement, maintain, and grow. This technology is so simple. You
Then
don't have too much of.
sorry to interrupt.
Go ahead.
Then how did we know what are the tables are inserted, what are the tables are there? Then if developers go and directly they can do, if this is a node dynamic schema, right? I mean, dynamically we can create a
And
schema. Then developers can go and create whatever they want. And how can we track all these tables and these details? It's not possible, right?
see, they will create as per the requirement. That's what is a product is needed. They don't want to define and load the data. They wanted what they wanted to load straight away. That's how these products are. You're not restricting them. You are giving the flexibility to them. You're
Okay.
asking the question on the
No,
flexibility.
no, Ravi, I'm asking in different way, but my question is, I'm asking in
I
different way.
understand.
But okay, but in SQL Server side, what I'll say is, okay, I have some product. For that they will give me the schema, right? These are these
I
many
understand.
databases are
Yeah,
there. These are the schema is available, and you can go and check whatever the relationship, foreign key relationship and primary keys, what are these, and table columns and all the things they will provide actually. And
right.
you can go and directly you can check. But in this case, how can we go and find these all these values, I mean schema
I understand. I understand. So if this happens, they will create all the junk collections, and then
collection?
it will
Yeah.
become a mess kind of thing. But it won't happen. See, if it is a production system, there will be due diligence. They do follow it. If
Okay,
you
okay.
are running a company, there should be people who should be aware of the how things work. They don't create every time they insert a new row. They don't create a collection. That
Yeah,
won't
yeah,
happen.
correct.
It is an application, right? You define
Yeah.
things. It will happen in the background. So don't think
Okay.
that way all the time. Maybe it can happen if there is no rule set defined. People are mad and doing everything what they wanted. That become a messy thing. But everywhere there will be procedure to do,
Yeah,
right?
yeah, correct.
So
Yeah,
that
yeah.
will control anyway.
Okay.
Right. So next, thriving the open source community. It is open source. See, all NoSQL will give you the open source, and the paid version and free version. Free version does not have any limitation in terms of data processing, except the features deprecation. Features will not be given, but data processing is absolutely as good as a paid version. That's a good thing. Now, if you go to RDBMS, it will follow the rigid schema. You define the schema, load the data within that structure only. If you violate the structure, it won't accept the data just now we've seen. So it is a dynamic schema. Data can be in any format. It doesn't matter. So there's a big difference. Vertically scalable. So one machine, more resources you'll keep added, the more storage you keep added, but you do on one machine. But here you will add more machines. In fact, not as the power comes in terms of more machines. The power comes here in terms of more addition of the resource on the same server. Difficult to handle the big data, large data. See, the product can be good enough to maintain, but you cannot do the rebuild, reorganizing, indexes. And if you cannot do it, what happens? The fragmentation can happen. If the fragmentation can happen, system will go and search entire data. The entire one query can choke the entire server. So managing the large data set on an RDBMS system on a single machine is a definitely difficult part. Here it can absolutely can handle because data is getting distributed to different servers. In fact, mix of open source and proprietary. Open sources are there. There is a huge limitations. There is a limitation. Even Postgres is open source, but does not deal with the huge data sets. It has a lot of issues. In fact, it's a buggy product. Okay. Open source, it absolutely open source. It can support large volume of data set, mostly standalone. It distributed to get the most of the benefit. It can also be standalone, but you get the NoSQL benefits when you run in the clusters. Single point of failure, no single point of failure here. So all RDBMS, if one file is down, entire database will be down. NoSQL, entire one shard is down, all other shards what are operational will serve the data. Still your cluster is up and running. This will follow the asset property. This will follow the base property. See here, you need a absolutely server class, server side sophisticated hardware to process the data because you're putting everything on one server. Here it runs on commodity, means cheap, dead cheap, any hardware. In fact, it is not a server class because you're not writing one request data into one server, right? It is writing into a lot of different servers. So the IO is getting distributed. So that's why the IO won't get choked up. It is
No
very
constraint
costly
like NEMV, SSD, and HDD. You can do any. You can use anything.
anything, of course. That's what, because
Okay.
distribution is happening, right?
Okay.
This is very costly in terms of licensing and maintenance as well. This is not. Is average compared to this. So if you are paying $100 here, you will pay roughly $30 to $35. So 60 to 70% it is cheaper than RDBMS products in terms of licensing. All of this. And types of NoSQL, there are many things, guys. Even I did not work all of this. I know just a little about, but MongoDB is my bread and butter in the NoSQL technologies. I did not work on any other RDB, the NoSQL technology except Mongo. Redis server, Memcached, and Scalaris, MongoDB, CouchDB, RavenDB, Bigtable, Cassandra, HBase, Hypertable, Infinite Graph, LagDB. These are all just the names. Just for the namesake, I kept it. I didn't work on all this, only except the MongoDB. Compared to after Hadoop, MongoDB is a next NoSQL technology which is leading in the market. Hadoop is the first, then MongoDB next in terms of market.
Okay. Here you mean if we learn MongoDB, then we can do CouchDB and RavenDB. Am I correct?
Yes, they are
Because this
similar
is a document.
architectures.
This is a document-based model.
Yes, they are very similar. As long as you get the environment, you might explore, but we don't have. So I didn't
Yeah.
explore that one.
Okay.
So introduction to big data. What is big data? In fact, big data is any data that cannot be handled and processed through traditional or single system. In fact, okay, it involves millions of users, millions of queries per second, billions of rows accessed, and wide variety activity at the same time. People read, write, and do handle with the different data. So it should be still handled by hundreds of servers in the background, not by one server. It follows large volume of data, wide variety of data like structured, semi-structured, unstructured. Velocity means speed. With a different data with a large volume. These are the big data features. In fact, volume, variety, velocity. Okay, if it is a RDBM system, you have to increase the CPU, RAM, disk, and everything in a single machine. High cost. If you are increasing RAM or anything, you need an absolute downtime on that one. Okay, threshold and limitations. It has limitations, right? It goes beyond certain size you cannot maintain because of the maintenance activities. Maintenance activities like rebuilding, if you run for days and days, business won't accept, right? And single point of failure. If you come to the NoSQL technology, they follow the horizontal, like this. Like you have one replica set, second replica set, third replica set. So add more machines as data is getting increased. Less cost, commodity hardware, no downtime. Basically, it will anything we do in a rolling fashion. We will fail over. If I have to do anything in the cluster, I'll fail over. I'll do here. Fail over. I'll do here. Rolling fashion. So you don't see the downtime. In fact, no limitation of the data, no single point of failure, can be scaled down with a huge data. It is absolutely scaled with a huge data. Now, RDBMS will follow the atomicity and NoSQL will follow the base property. So basically, all RDBMS will follow the atomicity. Atomicity means what? Basically, a data, like a transaction must be either completed or failed. It should not left in between, basically, right? That is talks about the atomicity. Consistency. Your data, even your system is rebooted, whatsoever happened, it has to come back. Roll forward, roll backward will happen by the system automatically. It will come back to the original data set. Isolation. At any point of time, one can access one data set, right? Two people cannot do it. There is a locking system. Durability. Durability, your data is never change on its own. It will be once it is written means written, basically. Basically available soft state here is, if you write the data here, there is no synchronous concept here, asynchronous by default. The replica set follow the asynchronous model only. If you want it synchronous, you can make one transaction synchronous. How you can do? You can do with the right concern. When you are writing the data itself, you can mention the concern. We have all that architecture. I'm going to talk about that. How you can make the data synchronous immediately, or how you can write asynchronously. We'll see that with the right concerns. And I did not finish this yet. We will talk about these features in the our modules anyway. So MongoDB used to call as a 10gen. Old name of the MongoDB is a 10gen basically. And yeah, go ahead, please.
Ravi, one doubt. Can you go back to that slide?
Mm-hmm.
No, not that rough diagram, the one where it's showing, right?
Yeah, wait, yeah.
Okay.
Yeah.
So here the replica server is pushing the data to its secondary. Okay. Yeah, that's one. Okay. So will it push the in case the replica server goes down, the secondary server will become primary, right? Okay.
Right.
So my question is maybe the replica server is not down, but still the secondary can be used for some other application as a for read only or updating any data.
Yes. You can use this for read. Yes, of course.
You can use for read. Okay.
Yes.
So that the data distribution can distribution can happen.
You can
Right?
use. Yes,
Okay.
yes. Actually, when you're reading itself, you can ask that read preference from secondaries.
Okay. The main replica for writing and the other secondary for reading. And
Yes,
but we
you
cannot
can
use
keep
that
that.
for writing. Right? We cannot use
Yes,
the
you can.
secondary set for writing, right?
Absolutely. What you said is correct.
No, can we use
mean,
that?
You
Hello.
cannot
I'm
use
sorry.
secondaries for writing. Only primary you can write. Will sync.
Okay. Okay. Got you.
Yeah, go
Thanks,
ahead.
thanks.
Right.
One question here in this. Yeah. So if it's not following the consistency operation, for example, you said this will be following by default asynchronous data sync between the
Right.
replica set, right? So for
Right.
example, if there's a transaction, it is writing 250 records as you're duplicating there. So while replicating this, while synchronizing the data asynchronously, the primary replica went down, that the read write copy. So how
Right.
was the secondary is going to pick it up?
That's a good point. Actually, that's why we will keep two servers in primary data center. So whatever the replication should happen first, at least to the local data center. That's why it instantly asynchronous, but it instantly happen on the secondary. Two are in the primary location, not too far, and the same LAN, and the other one will be far enough. So that way, at least you make sure that one copy is absolutely synced with a absolute high bandwidth. That's how things will be made.
Yeah, thank you.
Yeah. Any other question? Fine. Come back here, guys. The MongoDB incorporation, the old name is actually Tengen. Tengen itself is renamed to MongoDB incorporation. MongoDB absolutely distributed by the MongoDB itself. There is no third party involved for any tools. In fact, if you go to the on-prem Ops Manager, Atlas, Cloud Manager, all of the tools, whatever you have in the market for monitoring and managing the Mongo, everything is a MongoDB products only, basically. There are third party tools which can be used to administer the databases. Like you wanted to write the data, you wanted to migrate the data from SQL to Mongo, Mongo to SQL, or anything such kind of data. So this product is actually whatever the tools, most of the tools are Mongo distributed tools. You don't have too many third-party tools for this product because MongoDB is not, like involving anyone to be partnered and develop something. They do themselves all of that and distribute into the market. That's a great thing, basically. No need to go to any third-party vendor. There are third-party tools also to manage the Mongo, which are licensed. We have to migrate the data, in fact. So if at all example, Mongo follows the JSON format, JSON document model. Basically, we'll call it a JSON, okay, JavaScript notation. So it is so simple, and any LKG guy can understand. We will spend 4 classes on the CRUD operations. CRUD is equivalent to our DML operations in the Mongo. So if at all I wanted to convert my SQL data, this is an SQL data, right? I wanted to convert into Mongo, the same data. So it is so simple, in fact. Select asterisk from student, just for the sake, okay? There is something called for JSON auto, I guess. If at all I wanted to convert, okay, this is what. If at all I wanted to convert SQL data into Mongo, just I'll read the data like this. Select for JSON auto and get the output into Notepad. You don't do like this in the real world, but in a small data sets we can convert. Large data set you need a license tool, basically. db.lab.insert many. There is a small function many, and then I'll keep in the array all of the data. What is array? We're going to talk about this anyway.
Ravinder, I'm sorry to interrupt you again. This is Shiva here.
Yeah.
I'm little bit poor in the this
Mm.
no, JSON.
You don't have to be
So
worry about. You don't need to know anything at all. Anybody can understand. That level of knowledge I can give you. Right from intermediate level, you can write your own scripts by after 4 classes for sure. I'll guarantee you.
okay.
Okay.
Yeah, there is one more doubt for me. Is Mango database will support all kind of data like streaming data,
Yes.
history data?
Yes.
Okay, okay.
Any kind of data, in fact. Structured, semi-structured, unstructured means it's covering everything, in fact, in that. Okay. So now this is the Mongo data. I'm directly inserting this data into Mongo shell. So into lab collection. Collection, it is not there actually. It is going to create the collection. db.show collections first. Show collections. It is created a lab collection. See this db.lab.find. You'll get the data. This data came from the SQL to Mongo. So JSON, like document model is supported by all RDBMS systems. Mongo data easily can be converted from RDBMS to Mongo, Mongo to RDBMS. It is so simple. But if you wanted to deal with the large data sets, you definitely have to go to the third-party paid tools to convert the data. Data conversion, small data set we can convert in the SMS itself, basically. But a large data set you cannot do from the SMS. You have to definitely go to the third-party paid systems, RoboMongo, basically. Okay, Robo 3T Mongo, there is a RoboMongo tool, which is a paid and licensed tool. That tool can migrate the data from SQL to Mongo, Mongo to SQL. That we have done. So simple. It runs through few wizards, it will convert the data automatically.
Even Studio 3T also.
3T, yeah, of course. 3T is something, it's just a UI tool. Robo 3T, right?
Ravi,
You're talking about?
That's off.
This won't convert the data.
RoboMongo.
But RoboMongo can do it. Go ahead, please.
Ravi, I mean, do you have experience with migrating the data from SQL Server to Mongo?
Yes, I did. Mongo to SQL, SQL to Mongo. That is
I
so
mean,
simple anyway. I'll give that
is
links and all, like if you want.
yeah, is it covered in this course curriculum?
No, that is a licensed tool. We cannot do that.
Okay.
But I'll give the documents where you can just follow it. Just a few
Okay.
clicks away. You don't need to worry about that. It has to be
Okay.
licensed. That's the problem.
Okay. Fine.
Fine. So come back to the course, guys. What we're going to cover. Our course is divided into 10 modules. Anybody? Shiva, can you go on mute?
I'm sorry.
Right. So now, guys, the course is divided into 10 modules. In fact, first introduction to NoSQL is just a demo. So we will start the next class on the Unix basics. A lot of people from non-Unix background in the class. I know everyone almost. So people who are from the non-Linux background, they cannot catch if I start the product straight away. So as a DBA, what and all we need to know towards the Unix flavor as a OS side. I'm going to cover 2.5 classes, the entire thing what we need to know as a DBA. That's enough. Unix side, whatever I'm going to cover in 2.5 days, that's more than enough to run the Mongo, to manage the product, to survive as a DBA in the Unix flavors, and all flavors almost. Okay. So Unix administration will be covered in the next 2.5 classes. Then we'll enter into the architecture. What is Mongo server architecture? What are the things are there in the background? If the server crashes, how it recovers the data automatically? What are the things are there in the background? So the architecture of storage, in fact, how it will be retrieved, how it will be stored, it is compressed, non-compressed. There are many things in the architecture. Architecture especially important for the interview. There will be a lot of questions on the architecture. Here we'll spend 3 classes, in fact. CRUD operations, JSON kind of thing. It will run through the JSON. It is so simple, guys. I'll make you know, like right from the anybody can understand. I would guarantee that you don't know anything, any programs absolutely can write it. That simple it is. Schema design validation. This is where we again I said like Mongo can accept any data, but I wanted to restrict it. It should not take all the data what it has to, right? What we don't want. Basically we can define certain conditions. We can validate the data, then only accept the data. We're going to see that, especially performance tuning, guys. Performance tuning, we're going to spend really good time there. We're going to see that how we can improve the Mongo performance. How we can see the execution plans, how we can find easily that what kind of queries are going slow, why it is going slow, and what kind of indexes we need to introduce, what kind of pattern we need to build. I'm really expert at that side. So I'm going to really, give you great insight towards indexes and performance tuning. Administration, this is a major module for us, like installation, upgradations, migrations, and security, backup, restore, and all the major topics as a DBA, whatever you do on daily basis will be covered in this module. Okay, backup, restore, and these two modules are very, very important for us. Replica configuration with all the issues, sharding configuration with all the issues, and monitoring and third-party tools. How we can do the monitoring, how we can automate the Mongo backups, how we can recover the Mongo data. If you delete one collection, one row, one database, how you recover in the Mongo, point in time recoveries. So that will be covered in the replica set again. And with that, our course will end. And I have shared, I guess, 4 content with all of you, right? So it is a very extensive course, guys. If you understand all the classes, absolutely you can crack them too, for sure. You have to follow the classes thoroughly so that you can answer well. Okay. So any questions? I'm done from my side as a demo. Stay back,
Ravinder,
everybody.
seems I didn't
Any
receive
other?
this course content. Can you
Second time.
share with me?
Ravi,
Surya here.
Sorry, can you come again?
No, I didn't receive this course content document. Can
I'll
you
share it.
share with me?
I'll share it with the today's
Yeah, sure.
class. Yeah.
Yeah, sure. Thank you.
Ravi,
I
which
have
is
made
not
it a
covered here.
submission. Yeah, please
Wait,
go
wait.
ahead.
Yeah, go ahead, Santosh.
Any topic which is not covered in this syllabus, which is anything which we
As a
need to know?
no, as a DBA, whatever you need to know, I'm working, right? So I know what to be covered. So yes, as a DBA, you definitely get 90%, 95%, 5% maybe related tools. tools can be, like environmental, and then how they're integrated and all that.
Okay, so any exposure on the cloud?
Yes, I'll create a cloud machine. I'll migrate the data. How you can migrate? We'll see that with the replica sets. Data center
Okay, it's
migration, upgradation. Yes.
part
We're
of
going to see
syllabus,
that.
right?
Yeah.
Yes, of course.
Yeah,
Okay,
Ravi,
yeah,
this is
thank you.
Basant. The same question it was there for me actually. Atlas, would we be able to cover Atlas?
Yes, Atlas I'll cover. I'll create a free cluster. I'm going to show that how you can see the metrics, how we can deploy the changes from the Atlas. In fact, how we can create the user subscriptions. So how you can trace the things kind of on the Atlas. It's like a not with the paid version, free version Atlas I'll create. I'll run through one class there, of course. I'll give a fair idea how it operates.
Okay, fine, Ravi.
Yeah. Any other question?
I mean, we are going to do a migration also, right, from SQL to NoSQL. I mean, apart from the licensed tools, is there any way that we can at least have a demo of that?
This is how you can migrate if it is small chunk of data. Large set you have to migrate through the tool only, which is paid.
All right.
I'll share the like documents where you can go through and do it if you get a license tool. Okay.
Yeah.
It's so simple anyway. Go ahead.
Yeah, Ravi, Srikanth here. Don't mind, it might be the basic question. So I just confused with what is chunk, what is the shard, what is the replica set. So
Don't worry about the chunk. You don't need to worry about this. Is a very big module for us.
Okay.
This is something. Sharding is something giving you a distributed computing power or a model. Like you can write into one mongoose, it will go and write into multiple stuff. That you need to understand for now. We have a dedicated module for entire sharding architecture and configuration, and we're going to see how data moves chunk by chunk also.
One question here, since it came for terminology. So what is a cluster, sir?
Cluster, the entire concept is called cluster here.
Cluster.
Mongo cluster means it involves sharding methodology. Sharding in terms is called cluster is called sharding, interchangeable words.
Ravi, what about upgrades, patchings in Mongo? Are we going to cover it?
That's very important. Upgrades, migrations, and we're going to see that. In fact, that is very important topic. Yes.
Patching as well, right?
Yes, patching is so simple. Yes, I'll cover.
Do we have any creation of alerts, like getting CPU alerts?
You have to have good third-party tool for alerts. There is
But any scripts, sir?
Scripts and all we need to see, what can we do, but entire things is not available for all the things. Like you have CPU alert, memory alert, disk alert. You have to come through the third-party tools. If you need something, you have to go to the enterprise, like entire monitoring. Script something can do a minimal job, not entirely.
At least basic thing. If CPU threshold got, I just getting one
that
alert.
That is third-party tool. No, that is a third-party tool. The product does not give you that.
Okay, by any script, sir? By writing any script?
No scripts for that. You have to go to third-party tool, basically.
For getting those alerts? Okay.
Yes, so that is the OS, right? You're talking about the OS, not about the product. CPU, memory, disk is a OS.
Okay. So manually by using commands only we are seeing like Mongo top and Mongo stat, no?
That is different story. That is something. Why Mongo is taking more resources? We'll get into the troubleshooting side. Mongo top, and Mongo stats and all that.
The CPU alerts and this one, sir? What about CPU alerts?
That's what I said. You have to go to the third-party tools to trigger the events on the machine level. It's not the product level, right? CPU, memory, and all that.
Ravindra, I'm continuing with the same question. Is the tools have any free or it is a paid version only? The third
Which
party
tool you're
tools.
talking about?
The
Third-party
monitoring
tools are
tools.
there are, of course, paid version. They are all licensed.
Okay. Even we can for a testing purpose also we don't have a.
See, if you go to the SCOM, what it does, it will go to the machine and then monitor it. You have a Xenos, you have New Relic. There are tools in the market. They are enterprise tools. They will look at the machine metrics and generate the alerts. That is something is common across the enterprise, right, companies.
Okay, I'm continuing two more questions, please. Please bear with
Yeah,
me.
go ahead. Yeah,
Yeah,
absolutely.
I'm not aware about. Do we have a MongoDB? Do we have a support?
Yes, we do have, absolutely, but you only have the support for enterprise. For standard, the community edition, you have to pay for the support every year.
Okay, okay, okay.
Yeah.
And the last my question is, how is market about Mongo?
See, you understood the demo means you understood the it will have
Yeah,
the market. Why? Because
yeah,
certain
definitely,
things.
definitely. See,
Yeah,
I'm
it
being with
has.
this.
See,
Yeah, please.
Mongo is growing everywhere. In almost every company, at least some footprint is there now, like SQL. So everywhere they are using for a lot of different use cases. In fact, like applications, logs or server logs. At least if they don't have a Mongo use case, but still they're using the Mongo for generating the infrastructure logs and building the dashboards and all that using the different BI tools. Okay. So any questions? If not, I'll stop recording.
One last question from my side.
Yeah.
In this course, will you be explaining a basic idea on how to design an architecture for a MongoDB? If the customer wants
Yes,
to
yes,
init a
yes. That
setup, so
that will be there.
how should we design? Yeah.
Design in the sense there is nothing much design, but I'm going to talk about how you have to architect an application to
Right,
make
right,
a connection database. Yes, yes, yes. That will be
right.
discussed.
If
Yes.
the customer says, I have 100 terabyte of database going to be in next 1 year, so how do you design something like that?
Design is only
How do you,
starting. Design only the starting.
yes, yes,
As a
exactly.
DBA,
Like,
that is
how do we
that is
propose
the thing.
as a DB? Yeah, as a
SP,
DB, how do we
as a
propose?
DBA, you look at the metrics, you look at the thresholds, you look at the data set that server has. You have to recommend the sharding is a good thing for this because we are overloaded with one machine. So customer will get to know, you also get to know because data is growing anyway. They'll propose a solution, we will implement it anyway, or we will propose solution anyway. It will ultimately lead to sharding only when data is grows bigger on a single machine.
Right, right. The initial proposal, how should we propose to the customer? Like initial
You
setup,
have
we
to go
should
to the
be
metrics.
doing. Yeah,
Initially, don't do it. As it is growing, you have to do it. How you do it, we will see it in the course. Directly, we
sure,
don't go
Ravi.
to the shard straight away. Yeah. So I'm stopping the recording. I stay back.